Hey, so we're on problem 3 of our big box practice test. And on this one, it says create a scatter plot of the data in the table from 1A, so that's a couple pages back, to represent the total time traveled to the safe house as a function of distance that you choose to travel through the jungle. So what they mean by that is that total time versus it's written down here, distance travel in jungle versus total time travel to safe house. So distance traveled through, what's the best way to say this, through jungle, and this is in miles, and this is versus total time riding sideways, total time. And you know what I mean by that is like time traveled through the jungle and time traveled on the road, all put together. So this is in hours, I believe. Now, the first part of making a scatter plot is you need to come up with a good scale for your data. And if we look at our data here, remember this is the distance traveled through the jungle, and then just take a peek at these values. It looks like it goes from 3 to 5.2. So when we make our data values for our graph, let's go from, hey, let's start at 3. There's nothing that says that you need to start at 0. You can start at any number you want. And let's go by 0.2s, I'm thinking. So 3.2, then 3.4. I'm going to write really small. 3.6, 3.8, 4, 4.2. I'm skipping the line so I can fit everything. 4.4, 4.6, and 5, and 5.4, 5.6. Okay, that's as far as we need to go. Alright, then on the Y scale, let's check out our values for that. That is the total time. And it looks like it goes from 3 to our lowest value is 2.67. So we might go by like 0.05. So probably start at 2.6. And then go to 2.65, 2.7, 2.75, 2.7, 2.8. Okay, so I'm going by 0.5, so 2.9, then 3.0. Oh, I could probably stretch that even more. Yeah, I could probably go by 0.2s. Okay. Let's do it this way. So I can go by less than what I even did here. So start at 2.6, and then let's go to 2.62, and then 2.64, 2.66, 2.68, 2.7, 2.72, 2.74, 2.76, 2.8, 2.78. That's right, 2.468, 882, 2.82. It's kind of a long process, you know, but it's not too bad. 6, 2.88, 2.9, 2.92. Oh, great. Now I'm going to run out of space. 2.94, 2.96, 2. Oh, it's going to be perfect. 9.8, and 3.0. Woo! Okay. So then you just need to graph your data points. So if I go back to this page, we have 3 and 3. So that would be 3 and then up to 3. Okay. So maybe I'll use red. So put that point there. Go back, flip back a few pages. We have 3.2 and 2.74. Oh, that drops down a lot. And then we have 3.4 and 2.69. Okay, so I'm going to pause the video, put the rest of the points on there, and then I'll restart the video, and then we can check out our graph. So you go ahead and do your same on your paper. Just put the points on, and I'll see you on the other side. Okay, so we're back, and now I have all the dots plotted. Oh wait, did I do everything it says? So it says labeled axes, horizontal and vertical scales that fit the data, distance traveled through the jungle corresponding total time. Okay, travel to safe house. Okay. Okay, so we got everything. Okay, notice how this graph looks. It goes down, swoops down, then it starts to go back up again. Okay, and that's called like a parabolic type of curve. And what this graph is telling us is that as we go, as we travel further through the jungle, it starts to reduce our total travel time until we reach a certain point. Then, once we get to that point, about right here at 3.8, then our time starts to go back up. And as we travel further through the jungle, it starts taking us more time to travel to the house. Okay, so those are the key things to notice from this graph. So this would be the distance that you want to travel through the jungle, 3.8 miles. Okay, let's go on to our next problem.